Hi, this session is on the index laws we'll be studying this year. So pretty much all of them. And they're questions that I've chosen questions that are quite tricky and do confuse students at times. So there are a few useful tips that I'll be going through. And before we start, just make sure you understand the steps involved when working out questions involving index laws. Sometimes we have brackets, so your first step is always to expand your brackets, okay? In some questions you will see negative powers, so you have to turn any negative powers into positive powers, okay? And never leave your answer with a negative power as your final answer. They must be positive. Sometimes you'll, for example, have two fractions you have to multiply, so please simplify before you multiply. It's really important. And then of course, check, especially in a test, if you have time, go back and do the question again to make sure you haven't made a mistake. Okay, the first index law we're looking at is where we have the power 0. Now, we may not have covered this in class just yet, but it's really easy. And this index law is simply saying anything to the power of 0 is just equal to 1. So in this case, I've got a base 2, and I can see its power is 0. So that means the whole thing will just equal a 1, a whole number 1. That's it. So number 2, we can see we've got a bracket, and the power out there is a 0. So this is saying, we know this index law, when we have brackets, you multiply every power in the bracket, so all these have a power 1 with the power 0. And you can see what's going to happen. We will end up with everything, every base in here, being to the power of 0. And we know that means we're going to have 1 times 1 times 1, because anything to the power of 0 is 1. So the whole thing will just equal 1. So the trick is, whenever you have brackets and the power is 0, you know the whole thing, everything in that bracket will just equal 1. That's a shortcut. So with number 3, we pretty much have the same thing. Sorry, I forgot to put the power out the bracket. That should have been 0 there. So I'll just change that. So everything in the bracket will be 0. And don't forget there's a times there. And 2 times the 1 is just 2. So the whole thing will just equal 2. Number 4, we can see the base 2 has a power 0. 5 is just power 1, so that will be staying the same. 2 to the power of 0 is 1. And then we have 1 plus 5. And 1 plus 5, that hopefully isn't too difficult, is just 6. And that's it. Okay, the next thing we're looking at are questions involving negative powers, and I'm going to cover a few that will trick you if you haven't done this already. So let's just recap on what we do when we see negative powers. So we know the trick, and that is, if you have a negative power that's sitting above, so in this case everything is above 1, you grab the base and it's negative and it goes on the bottom and it becomes positive. So this 5 here had a positive 1, so it stays on top, but the x to the power of negative 2 becomes a positive on the bottom. Okay, with number 2, we once again have a similar thing. So, but in this case, it's being multiplied by b to the power of negative 2. So we know everything is sitting over a 1, including the b to the power of negative 2. So these two bases and their powers go on the bottom. So we end up with here the same thing as on top, 5 over x squared times, in this case, the 1's on top. Don't forget there's an invisible 1 there. 1 over b squared. And now simplify before we multiply. With this question, there's nothing we can simplify, so let's just multiply. 5 times 1 is just 5 over, we've got x squared times b squared. We'll do it alphabetically, so we'll end up with b squared and x squared on the bottom. And that's it. Okay, with the next two, I want you to have a go with these ones. And like I said, they might trick you a little bit. Let's see how you go. All right, so with the first one, pretty straightforward. Every power in the brackets gets multiplied with that negative 2. Okay, so I end up with x to the power of 2 times negative 2 is negative 4. And then b that has the power 1, so 1 times negative 2 is negative 2. Sorry that it's lagging a little bit. There we go. Now, I've expanded my brackets, but I don't stop there. My final answer cannot have negative powers. So I've got to turn these into positive, and because they're both sitting above a 1, they just go on the bottom. So on top, I make the 1 visible over x to the power of 4 and b squared. Or you could have had b squared and then x to the power of 4. And that's it. Number 4, we're doing the exact same thing, except that we've got times separating these two expressions. Now, you can approach this in 2 different ways. You can add the powers of the same base, because we are multiplying. Or if you wanted to, you can turn the negative powers into positives first and then simplify. So I'm going to do the second option to practice flipping my variables and their negative powers. But remember, if you went -1 plus -3, that's still the same thing. You still get the same answer. But I'm going to turn negatives into positives. So that f has a -1, and these both have negative powers. So this one has to go on the bottom, okay? So I end up with g to the power of 3 stays on top, but f goes on the bottom. And it's now a positive times, and these are both negative powers, so the 1 stays on top, the invisible one, over f to the power of 3 and g to the power of 4. All right, so you should have had that for now. And now I'm going to simplify before I multiply. So I'll just rub off this top question here so I can have more room. And simplify before I multiply. Both my f's are on the bottom, but I've got 3 g's on top and 4 on the bottom. So I'm going to cross off my smallest amount, that becomes a 1, and 4 take away 3 is just 1. So I have 1 g down there. So my final answer will be, I'll just write what I've got left. I've got 1 over f times 1 over f cubed g, and multiply this out now. I've simplified before I've multiplied. So 1 times 1 is 1 over f times f to the f cubed. 1 plus 3 is 4, so I should have f to the power 4, and g just sits there. And we're done. Don't forget to add the powers of f. They have the same base, and we are multiplying them. So that should have been your final answer. Okay, I want you to try this next question. We're still doing negative powers. I remember putting this in a test once, and most students got it wrong. Now, I'll give you a tip. You also have to think of your fraction skills and BODMAS skills and so on. But remember, turn negative powers into positive powers. So have a go first, and I'll get started. So my first step is, I can see every base here has a negative power. So that means I'm going to flip them all and put the invisible one on top. So I'm going to have 1 over 4 cubed times 1 over 2, or 2 to the power of 1, divided by 1 over 12 cubed. Okay, so that's my first step. All my powers are now positive just by flipping. Then my next step is, I'm multiplying. I've got fractions now, and I'm multiplying and dividing. Now, I know with my fraction skills, if I have division, I've got to turn it into times. So to do that, I have to flip the 1 and 12 cubed. So that will be my next step. Okay, if you've got any fraction skills, you need to practice some questions on that. Division with fractions, turn it into times. So I end up with 1 over 4 cubed times a half times 12 cubed over 1. So now it's flipped back again, okay? But it's still positive because I've already changed it. And now I can hopefully simplify or evaluate. So have a look at and see, all of my bases are different. So unfortunately, I can't simplify any of these bases. So I will evaluate my numbers. So 4 to the power of 3, or 4 cubed, I've got 1 over 64 times a half, will stay the same, times, then I've got 12 cubed, which is 1,728 over 1. Now I need to simplify before I multiply. I'm going to try and divide 1,728 by 64 and see if that works, and it does. So 64 can go, and I end up with 27 up here. You could have divided the 2, but I thought I'll get rid of my larger number first. So I made some room on the top. So this should equal 1 times 1 times 27 is just 27 over 2. Okay, and we have an improper fraction, so you can turn that into a mixed fraction. So we end up with 13 and a half. Okay, and that's it. All right, have a go with our next question, and I'll get started. Now, some of these questions I have taken from your textbook or changed them around a little bit, so they may look familiar. All right, so with this one here, straight away I can see I've got negative powers. So before I simplify, I will take care of my negatives. So I can see I'm going to circle my negatives. So that base 4 has a -1. That's got a negative, and everything else is positive. So they are the only two bases that will be moving. So they'll be both going on the bottom, and everything else will be staying where it is. So what I like to do is I write down what will be staying. So that will be staying, and everything on the bottom is staying. So I'll just write that out. And I'll put a times here. So whatever comes on the bottom can go on the end there, just to remind me I'm multiplying it. So this 4 to the power of -1 goes on the bottom, so times 4, and then y will become y squared on the bottom. And now I will multiply what I need to, so I'll just make more room. And so x cubed stays on top on its own for now, and now I've got 4 times 4, which is 16, and then m squared stays the same, x to the power of 4 stays the same, but y cubed times y squared, same base, I add the powers. I end up with y to the power of 5. And now I do a check. I can see that I can simplify something, and that is my x. So I've got 3 x's on top and 4 on the bottom. Cross off my smallest amount, it's just 1, and 4 take away 3 is 1. So my final answer is 1 over 16m squared x and then y to the power of 5. And that's it. Okay, with our next one, this one might confuse you. Now remember, you can see there are 2 negatives. One is just a big negative in front of the whole number, whereas that negative is a power 3, okay? So just keep that in mind. All right, so with this one here, I've got a -2 on top, but its power is a positive. So that means that won't be moving at all. And because I've got one big negative in the whole thing, I know my answer will be negative. So really, they could have put this negative in the middle, but they put it up there to confuse you. So I'm going to, in my final answer, have it in the middle, so saying the whole thing's negative. And now I have to turn this power that's -3 into a positive by putting it on top. All right, so the 2 stays there, so I'll put my times there to make it visible, and I've got 5 to the power of 3 on top. On the bottom, it's just a 1, so nothing has to stay there now. That can be invisible. So I end up with minus, and now what is 5 to the, I can't go 2 times 5 is 10, be careful. Evaluate your powers first. So 5 to the power of 3, so I've got 2 times 5 to the power of 3, which is 125. And it's a negative, and so my answer I know it is negative, and 2 times 125, or double it, is 250. So hopefully you ended up with a negative 250 for that one. Now next, these questions now involve an important skill when you see negatives in brackets. Now I forgot to mention, if my numbers are wrong, like numbering my questions, I'm sorry, because I totally lost count, so I'm just guessing. I think I'm up to 7, 8, and 9. Anyway, so have a go with these questions. If you can't do it mentally, or if you're not sure, put it in a calculator and see what happens as well. Now with this one here, I notice it's really important now. This big negative out here is in the bracket, okay? So what's actually happening is we're saying 2 squared, or 2 times a 1, but we're also saying there are 2 negatives because it's included in the bracket, all right? So and another way of looking at it is, this is saying -2 times -2. And 2 negatives, we know an even amount makes a positive. And then 2 times 2, or 2 squared, is 4. So you should have had +4. So the whole point is, if your negative is in the bracket, it's included. So it has to be squared, or it's saying 2 negatives. See number 8, is that negative in the bracket? No, it's not, okay? So it's not included. So we're just saying 2 times 1, or 2 squared. So we end up with the negative stays on the outside, and 2 squared is just 4. So that one would have been a negative 4 because this was on the outside. Number 9, the negative is inside. So we're saying to multiply a power. So 1 times 3 is just 3. But we're also saying 3 negatives. And the trick is, if there is an odd amount, we know the answer will be negative because, or the other way of looking at it is minus 2 times minus 2 times minus 2 will give us a minus 8, okay? And then 2 to the power of 3 is 8. So just remember, when the negative is in the bracket, it's included. So have a go at this next question, and remember that important step. The negatives in the brackets, it's included. So with this one here, I've got a power 4 sitting outside. Sorry, a bit lagging. I have to multiply every power in the bracket. So that's got a power, that's got a power, that one, and that one. And remember, that negative sitting outside also gets a turn, okay? So 4 negatives will make what? 4 of these will make a positive. So I know my answer now. There's no other negative anywhere, inside or outside. My answer will be a positive, okay? Because I can see there'll be 4 big negatives. And then just do your powers. So I have 2 to the power of 4. 2 times 4 is 8. So A to the power of 8. And then B to the power of 4. And C to the power of 12. And now I will evaluate my 2 to the power of 4, which is just 16. And I can see there is nothing I need to simplify for this one. So that is my final answer, okay? But the most important step was, remember, it's a positive answer because that negative is included in the bracket. And we're saying, according to this power, we're saying 4 negatives, 4 big negatives. Okay, the next few questions we're looking at involve fractional powers, okay? And I think I came across some of these in your textbook. And these are just as easy. Students look at these and freak out. All you have to do is apply the same index laws, but just you're adding or subtracting fractions. That's it. So the first one, x is our base. It's the same base, so we add the powers. So we end up with x to the power of a half plus a half. And what's half plus half? It's just 1. So we end up with x to the power of 1 or just x. And the next one, we're dividing, so we know we subtract our fractions. So we end up with 3 over 4 or 3/4 take away 1/2. Now, if you have forgotten your fraction skills, remember to subtract or add, you have to have the same denominator. This one here, our denominators were both 2, so we didn't have to change anything. This one here, I'm going to turn my 2 into a 4. So times by 2 times by 2, that's my lowest common multiple or denominator. I'll end up with, I'll just do the working out here for the fraction. So I've got 3 over 4 take away 2 over 4. And what's 3 take away 2? It's just 1. So my final answer will be x to the power of 1 over 4 or 1/4. And you could have worked that out maybe mentally as well, but that's how we do it mathematically. And that's it. So when you see fractional powers, don't stress. You just apply the same index law. In this case, we had to add and then subtract. All right. So the last one for this session, I don't want to go over 20 minutes. I've numbered it a smiley face because I don't know what number to put. So have a go at this one first. So we know our first step is to expand our brackets. So everything outside the bracket, everything in the bracket gets multiplied by the power 2. And the same thing on this side. I can see negatives, but that's fine. So I end up with x to the power of 6, y to the power of 2 over t squared, divided by for now. And keep that in mind, we've got division here, okay, not times. X to the power of negative 3, and t to the power of negative 6. Minus 2 times a positive 3 is minus 6. Now, my next step is to... Now, you can actually decide what you want to do next. Because we've got division here, we've got to change it to times. And that means we have to flip the fraction on the right-hand side. So you can do that first, or if you wanted to get rid of your negative powers, you can do that first. So you decide what you want to do. I am going to turn my division now into multiplication, and I'm going to flip my x to the power of -3 and t to the power of -6. So that's the step I'm choosing. So I'll just make more room. So I have on this side x to the power of 6, y to the power of 2 over t squared. Now times, so I've flipped my t and my x. Okay, and now you can see what's going to happen. I'm going to have to flip it again because I've got negative powers. This will go on top and that will go on the bottom. So in this case, these two just flip as well. So I'll write it out again. So x to the power of 6y squared over t squared times, this time, a positive x cubed over a t to the power of +6. Okay, so we've finally done that. I'll just make more room. And now you know what to do. First step, simplify before we multiply. Unfortunately, there's nothing we can simplify from top and bottom that I can see. So I'm going to now multiply this out. So we'll start with my x's, so x to the power of 6 times x to the power of 3. Or if you wanted to, what you can do is write your bases. So I've got an x on top and a y and a t on the bottom, if that helps. Write your bases first. And then the powers of x, 6 plus 3 is 9, y squared is the same, and t, 2 plus 6 is 8. And that should have been your final answer. So if I have made a mistake somewhere along the way, just put a post up, because I do make mistakes sometimes. Hopefully that's helped, and please make sure you keep practicing. Thank you.